You know, for decades, people have said that trying to predict the stock market is a fool's errand, that it's just a random walk. But what happens when you unleash a really powerful AI on 5 years of financial data? Can it actually find some kind of order in all that chaos? Well, we're about to find out.
So just take a look at this chart. This is the 5-year price history for Reliance Industries, a massive company in India. And yeah, sure, you can see a general upward trend, but if you look day to day, it's just a total jumble of peaks and valleys. This apparent randomness is actually the foundation for a classic theory in finance.
And that theory is called the efficient market hypothesis. The core idea is actually pretty simple. All the information out there, news, earnings reports, everything, is already baked right into a stock's price. So trying to guess where it's going to go next, it's like trying to predict a coin toss. You just can't get an edge.
But, and this is the really exciting question, what if our human eyes are just missing something? What if a machine learning model could stare into this chaos and spot hidden signals? Patterns that are completely invisible to us.
So that brings us right to the heart of the puzzle we're trying to solve today. Is the market's famous random walk really and truly random? Or is there maybe some hidden order, a structure buried in all that noise that we just haven't been able to see until now?
To get to the bottom of that, we're going to dive deep into this really fascinating data science project that tried to do what everyone says is impossible: to crack the code of a stock's price using a powerful AI model.
All right, here's the setup. The team took 5 whole years of daily stock data for Reliance Industries. That's over 1,300 days of information. The goal? Simple but incredibly ambitious. Use all that history to predict the closing price for tomorrow. And their weapon of choice was a machine learning model called LightGBM. Just think of it like a super smart team of experts, where each one learns from the last expert's mistakes, getting more and more accurate. It's famous for being both wicked fast and incredibly precise.
So how in the world do you teach a machine to do something like this? Well, you can't just dump a long list of prices on it. You have to treat the AI like a detective and give it some really good clues to work with.
This whole process has a name. It's called FeatureEngineering. Basically, instead of just showing the AI the raw price, you create brand new data points, new clues from that history, things like trends, momentum, and volatility.
A perfect example of one of these clues is the simple moving average. By averaging the price over, say, the last 10 or 50 days, you get to smooth out all those daily jitters. It gives you a much clearer picture of the stock's real momentum. Is it trending up or is it trending down? For an AI, this is a crucial piece of the puzzle.
And this right here, this is the proof in the pudding. It's a correlation heat map. And those dark red squares are basically revealing a powerful secret. They show that the price, the 10-day moving average, and the 50-day moving average are all super tightly linked. We're talking correlations over 0.93. For the AI, this is like a giant neon sign just screaming, "Hey, pay attention, these clues are the key."
Okay, so with all that training done, the AI was ready for its final exam. It was time to unleash it on data it had never seen before to see if it could really predict the unpredictable. And the results, honestly, they were stunning. So what the researchers did was they held back the final 241 days of data. The model had never ever seen this period. It had to make its predictions one day at a time using only information from the past, just like a real trader would have to. This is the ultimate test of its forecasting ability.
And on that completely new, unseen data, the model achieved an R-squared score of 99.98%.
Yeah, just let that number sink in for a second. What that means is the model could explain nearly every single wiggle, every turn in the stock's price. It is about as close to a perfect score as you can possibly get. It just shows how powerful those clues we fed it really were.
And this chart, this shows you what 99.98% actually looks like. The solid blue line is the real stock price over those 241 test days. And that dotted red line, that's the AI's prediction. I mean, you can see it just tracks the real price with breathtaking accuracy. It nails the ups, the downs, the overall trend. It almost looks too good to be true. And you know, whenever something in finance looks too good to be true, it is definitely time to read the fine print. Because while that headline number is absolutely incredible, there's always a catch. So, we have to ask the question, is this model really a crystal ball, or is there something a little more subtle going on under the hood? Let's look closely at this chart again.
especially that period after June 2025. Do you see that little gap? The prediction is consistently just a little bit behind the real price. When the stock really takes off, the AI is always playing catch-up. It's almost like it has a built-in fear of heights. It consistently underpredicts the peaks.
This chart here is the smoking gun. It actually shows us the model's mistakes. Now, in a perfect world, all those little dots would be scattered evenly around the zero line. But look here, we see this huge cluster of errors on the right side. This is the hard data proving what we just saw with our eyes. The model is a bit of a pessimist. It consistently predicts a lower price than what actually happens.
So this all leads to a really crucial question. If the model is so incredibly accurate, but it has this one specific flaw, what was the single most important clue it was actually using to make its decisions? And here is the final amazing twist. This chart shows how important each clue or feature was. After all that complex work creating moving averages and momentum indicators, the single most dominant feature, by a massive margin, was basically just the closing price from the day before. The model's biggest takeaway was that the best predictor of tomorrow's price is, well, today's price.
So, here's the bottom line. On the one hand, AI is an unbelievably powerful tool. It can find these deep historical patterns with insane accuracy, and that gives you a real quantitative edge. But on the other hand, it is not a crystal ball. Because it leans so heavily on what happened in the past, it's always going to lag a bit during sudden, sharp market shifts. It doesn't know anything about a surprise earnings report or some big global event, and it absolutely cannot predict a true black swan catastrophe.
You know, the authors of the study really summed it up perfectly. It turns out the market isn't a completely random walk after all. There's a real structure hidden inside all that chaos. And if you give it the right clues, machine learning can provide a serious edge. It's not about predicting the future with 100% certainty, but it is about stacking the odds in your favor.
And that leaves us with a final, kind of mind-bending thought. This AI got to near perfection by looking only at the past. So what happens when we give it eyes to see the present? What could it predict when we start feeding it a constant, live stream of news, of social media sentiment, of global economic data? The age of AI-powered prediction is really just getting started, and the stock market might never be the same.